Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving find the count of good integers. So the problem states that we are given two positive integers n and k. And an integer can be k palindromic if it's a palindrome and if it's divisible by k. And an integer will be called good if it can be rearranged to form a k palindromic integer. So for example, if k is equal to 2, 2020 can be rearranged to form the integer 2002. And then it will also be divisible by 2, so it can be considered a good integer. And we want to return the count of good integers that are divisible by k and containing n digits. So if you look at this example, where there are 3 digits and divisible by 5, there are 27 good integers in that range. And we'll go over it later, but some of the ones we see can be 551 because it can be rearranged to form 515, which is divisible by 5, and then also 525 because it is already k palindromic. So now that we have seen some examples, let's get to how we can solve this problem. So in summary, one way that we can solve this problem is first we find all the combinations of palindromes that are divisible by k, and then for all the combinations we want to find all the permutations that we can make from each combination, and finally we can return the total number of good integers from that. Now in the first step where we are finding all the combinations, we realize that we don't actually need to iterate through every single number. Rather, we can just look from the base to base times 10, and base will use this formula. 10 to the n minus 1 divided by 2, floor division. So for example, if there are only 6 digits, then we will only need to search from 100 to 1000. And the reason for that is we actually only need the first half of it, and then the second half can mirror it. So if there are even numbers of digits, we'll take the first half, and then the second half, we will just mirror it, and then we can check if it's divisible by k. If it is odd, we will take the first half, and then we will mirror the second half minus the middle element, and then we can check if that is divisible by k. If it is, then we will add it to a set, and then make sure we always sort the string before we add it to a set to avoid repetitive combinations in a set. And now that we have found all the combinations of strings that can be divisible by k, then we want to find the number of permutations that each combination can cause. So how we can do that is we can make a count array, and each index in the array will be represented by the digit number. So for example, in this string, 1 is represented twice, and 2 in index 2. So 2 will be represented once over here. And how we can calculate that is we can take the factorial of the length of the string, which is 3, divide by the factorial of each of these elements. And the factorial of 0 is 1. So if I want to include it all, it will be factorial 2 times factorial 1 times factorial of all these zeros, but I just didn't include them because they're all 1s. And the factorial 1 is 1 too, but I just put it here just because. So if you divide that, it will be equal to 3. And as you can see, there are 3 permutations of this combination. Now there is an edge case if there's a zeros in the string, because we cannot have a leading 0 as a permutation. So there's only 2 permutations in this example. And how we will do that is rather than take the factorial of the length of the string, we will take the length of the string minus 1 times the factorial of the length of string minus 1, and the denominator will be the same thing. So as you can see, there are 2 permutations for this combination. And for each number of permutations we find, we will add them to the result, and in the end we will return the total number of good numbers that we can make. So now let's go over this example real quick. So first we need to find all the combinations, and we realize that we only need to look from 10 to 100, or 10 to 99 to be more exact. And to save some time, I don't have time to loop through all of it, but here are all the combinations that can be divisible by 5. And by the way, just to remind you guys, some of them are sorted. Obviously 559 is not divisible by 5, but it was 595 and it got sorted to 559. And the reason we sort, again, is to avoid repetition. So now we need to check for each combination how many permutations they are. So in the first one, there's 2 permutations, add 2 to result. In this one, we add 3 to result, add 3 to result, add 3 to result, add 3 to result again. And for this one, there will be only one way because it's 555. So add 1 to result, add 3 to result, add 3 to result, add 3 to result, and add 3 to result. And since now we're at the end, we can return 27 as our result. And as you can see, there are 27 good integers that can be made. So the time complexity of this problem will be O of n log n times 10 to the m. So m will represent this part right here. And so the 10 to the m will come from the number of potential k palindromic integers that we can make, and then we will have to loop through them and calculate the permutation. So that's why 10 to the m is here, and the n log n is because for each of these numbers we will have to sort them, so we avoid repetition. We add it to a set, and the space complexity would be O of n times 10 to the m, where n obviously represents the number of digits and 10 to the m represents the number of combinations that we can make, and it comes from this formula. So now let's get to the coding part. So first we will initialize the palindrome combinations to an empty set, and base would be 10 to the power of n minus 1 for division by 2. And skip, so depending on odd or even, if it is odd, we'll set skip to 1 because we need to skip the middle element. Otherwise, skip will be 0. So now we will search from base to base times 10. And we will set the number to a string, and then we need to add, so we will reverse the string, and then we can add this as a mirror. So from index skip to the end. An integer, we'll set it back to an integer. So we'll call it integer, and if the integer is divisible by k, then we will add it to the palindrome set. Joins, and then make sure it's sorted. And then palindromes dot add string. And we'll initialize the result to 0 now. So now we're looking through all the combinations and we're calculating the palindrome. So we'll have that count array, and then now we look through the string and increase every number by 1 if we see a number in that digit. And now we're calculating the total. So n minus count of 0 for the edge case if there are zeros times the factorial of n minus 1. And now we will look for x and count, and total for division by the factorial of x. Look through the count array, and then now we will add total to result, and then now we can return result. See if it works. Okay, perfect. Hope this is helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them down in the comment section, and I hope to see you all again soon.